Assalamualaikum warahmatullahi wabarakatuh and a very good morning. In this video, we are going to learn about sampling distribution for P refers to proportion. So the concept of proportion is the same as the concept of probability of success in a binomial experiment. Okay, so the probability of success in a binomial experiment represents the proportion of the sample or population that possess a given characteristics. Okay, given that we have a population and we want to find the proportion of the population. So the proportion for the population is defined as pi. So how can we find the proportion of population is given as this formula x over n. Given the capital X refers to number of elements in the population that possess a specific characteristics, which refers to the number of success in population. And the capital N refers to the total number of elements in the population. Okay, here pi refers to the proportion of success. It is not refers to the pi number, which is 3.1423. Okay, so from this population, we can choose a sample. Okay, we're given that the proportion of sample is defined as small p. And the formula for the proportion of sample is given x over n. Given that x is the number of success in the sample, okay, which refers to the number of elements in the sample that possess a specific characteristics. Meanwhile, for n is the total number of elements in the sample. So the proportion of sample would be x over n, number of success over the total number of elements in the sample. So each sample will give a different value of p. Therefore, the proportion is a random variable and we symbolize it as capital of P. So the mean and variance of the sample proportion P, given that the mean of P is mu P is equals to pi, where this pi refers to the population of proportion. Okay, and the variance of P is given variance of P is equals to pi times with 1 minus pi over n. So by the central limit theorem, where this one has been explained in the sampling distribution for mean, okay, which states that the relative frequency distribution of the sample mean for any population is approximately normal for large sample such that n is greater than or equals to 30. So the distribution of the proportion is approximately normal and can be written as P follows normal given the mean is the population proportion and the variance is given pi times with 1 minus pi over n when n is large given that n is greater than or equals to 30. So when we approximate binomial distribution with normal distribution, we use the continuity correction factor of plus minus 1 over 2 is used. Since the proportion is equals to x over n, then a continuous correction factor of plus minus 1 over 2n is used. Okay, it's quite different from the normal approximation of binomial because we use 1 over 2, but for the proportion we use 1 over 2n. Okay, the way we use the continuity correction factor is just the same like the normal approximation of binomial. Okay, let's say we have to find the probability of the proportion equals to A. So after the continuity correction factor, it will be the probability of A minus 1 over 2n less than P less than A plus 1 over 2n. And for the second one, we want to find the probability of proportion less than or equals to A. So after the continuity correction, it will be the probability of P, probability of proportion less than A plus 1 over 2n. So what's the difference? Is just this value 1 over 2n. Okay, and then you can go through the rest of the symbol. Okay, now let's try the example. Okay, 30% of pipes in the chemical plant showed sign of serious corrosion. So a survey was done and a random sample of 100 pipes in the chemical plant was selected. So this one refers to the N, which is equals to 100. So find the probability that more than 35% of pipes in the chemical plant showed signs of serious corrosion. And from 20% to 30% of pipes in the chemical plant showed sign of serious corrosion. So now, let's try to solve this. So here we have our P where it represents the proportion of chemical plants showed serious corrosion. Okay, and then from the information we obtain here, we know that the sample is given as N equals to 100, and then and 30% of pipes in the chemical showed signs of serious corrosion, where this refers to pi equals to 0.3, the proportion of the population, meaning that the proportion of chemical plants that showed serious corrosion is 0.3. So we can write this proportion follows normal given the mean is equals to the population proportion and pi 1 minus pi over n, or this is normal given 0.3, 0.3 times with 0.7 over 100 is equals to 0.0021. Okay, so now we can solve for A. So more than 35% of pipes showed signs of serious corrosion. So the probability that the proportion is greater than 0.35. So remember, since it involved the proportion, we have to use the continuity correction, given that so 0.35 is not included, so we will add part here 1 over 2n. So P will be P greater than or equals to 0.35 plus with 1 over 2 times with n, which is equals to the probability of proportion greater than or equals to 0.355. So now we can solve using the standard normal distribution, given that Z is greater than equals to 0.355 minus with the mean, which is 0.3, divided by the standard deviation, which is square root of 0.0021. So here we get Z is greater than or equals to 1.2. So the area for this one that we need to consider is this. So from the table, what you need to do is you have to find 1 minus probability of Z less than equals to 1.2. So you will get 0.1151. So that is how we solve for question A. Next one. Okay, from 20% to 30% of pipes in the chemical show signs of serious corrosion. So we want to find the probability from 0.2 to 0.3. So which means that both 0.2 and 0.3 is included. So which means that the interval will start from here and here. Okay, so using the continuity correction, this would be 0.2 minus with 1 over 2n less than proportion less than 0.3 plus with 1 over 2 times with 100, which is equals to the probability of 0.195, 0.305. So using the standard normal distribution, this would be minus with 0.3 divided by square root of 0.0021, 0.305 minus with 0.3. So you get negative 2.29 and 0.11. So the area would be between this. So using the table, your answer should get 0.5328. Okay, now I want you to pause this video and try out this example. And you can check your solution with the solution I've provided in the slide. Now we go to the sampling distribution for the difference of two proportions, P1 minus P2. Suppose that we have two binomial populations, P1 and P2, given that the first population of P1 have the proportion of success pi1 and the sample of size n1, and given that n1 is large, so the sampling distribution of proportion for P1 is given as P1 follows normal, pi1 minus pi1 over n1. So this is for variance and this is for mean. And the proportion population for P2, given that the proportion of success is pi2, sample of size is n2, given that n2 is large, and the sampling distribution of P2 would be follows normal, given the mean is pi 2 and the variance is pi 2 times with 1 minus pi 2 over n2. So now we are interested in finding out the sampling distribution of the difference between two proportions given that P1 minus P2. So the mean of these two different proportions would be pi 1 minus pi 2. Okay, and the variance of the difference between two proportions is given as pi 1 times with 1 minus pi 1 over n1 plus with pi 2 1 minus pi 2 over n2. Therefore, using the central limit theorem, the distribution of P1 minus P2 is given as P1 minus P2 follows normal given the mean is pi 1 minus pi 2 and the variance is pi 1 1 minus pi 1 over n1 plus with the variance from the population 2 which is pi 2 times with 1 minus pi 2 over n2. So given that the standardized variable is P1 minus P2 minus with the value of mean divided by the value of the standard deviation of the difference of the proportion. Now let's try the first example. A production manager claims that his two machines will fail due to continuous operation and will produce defective products. So an investigation was done and it was found that the claim was true. So 50 out of 500 products from machine A and 45 out of 500 products from machine B are defective. So here we have two machines. The first one is machine A and the second one is machine B. So 50 out of 500 can represent our proportion. Okay, given that proportion is x over n. So given x is 50 products that is defective, so x will be 50 over the number of population which is 500, which is equals to 0.1. So that will be the proportion for machine A. And then for machine B, it will be 45 out of 500 defect. So it is equals to 0.09. Okay, 100 products from each machine are selected randomly. So 100 products refers to the number of sample. Number of sample from machine A is 100 and also number of sample from machine B is also 100. So suppose PA and PB are sampling proportions of defective products produced by machine A and B respectively. So the proportion of A is so if we write down the distribution, so it will be the mean of this PA would be equals to the population of proportion from machine A which is 0.1. Okay, and then for the variance it will be pi A times with 1 minus pi A divided by n which is 100. So here will be equals to 0.1, 0.0009. Meanwhile, for the proportion B, which follows normal, given that it is 0.09, and this one would be 0.09. 1 minus 0.09 over 100. This would be normal 0.09, 0.000819. Okay, so we have the distribution for both A and B. Next, we can find the question here. Find the probability that proportion of A is smaller than proportion of B. So the probability that proportion of A smaller than PB here would be equals to probability of proportion A minus with B less than 0. Okay, however, we still don't find the distribution for PA minus PB. So let's find out what is the distribution for PA minus PB, follows normal. So for the mean, it will be the proportion A, the mean from proportion A minus with the mean from the proportion B. So here would be 0.1 minus 0.09, and the variance from the proportion A plus with B. So it will be 0.0009 plus 0.000819. Get 0.01 and 0.001719. So now we can solve our first question. Given that the probability of PA less than PB equals to this, so we can solve this using the standard normal distribution. Given Z less than 0 minus with the mean of the difference of proportion divided by the square root of variance. Which is equals to the probability of Z less than negative 0.24. So the area covers here. Okay, because this one is 0. So you can get from the table, the value is 0.4052. So that's how we solve for question A. So now let's try for B. The probability that the modulus of PA minus PB is less than 1.8%. Which is less than 0.018. So first, let's solve this modulus. Okay, we know that if we open this modulus sign less than 0.018, it is equivalent to the probability of A minus probability of B less than 0.018 plus with the probability of A minus with probability of B greater than negative 0.018. So if we rearrange this, it will be probability of A minus probability of B less than 0.018 greater than negative 0.018. So we can rewrite this, which is equals to the probability of negative 0.018 minus PB less than 0.018. So using the standard normal distribution minus with the mean divided by the standard deviation less than z less than so it will be between negative 0.68 and 0.19, where here if we draw the area, it will be negative 0.68 and 0.19, which is equals to 0.3271. Okay, so that's how we solve the question. So if you notice, for the difference of the proportion, we don't have to apply the continuity correction. So the continuity correction is only applied for the proportion, one proportion only. And the last example is to find the probability that PA minus PB is at least 1%. So it would be greater than 0.01. Which is equals to the probability, so we can apply the standard normal distribution z greater than or equals to 0.01 minus with the mean divided by the standard deviation which is z greater than or equals to 0. So it is half of the graph, which means it is equals to 0.5. Pause this video and try out this by yourself, and then compare your solution with the next slide.